Ladies and gentlemen, good evening. Tonight we're going to look into the one-to-one JPA mapping, where we use a JoinTable to make the mapping. I've already showed you how to use a column, where you can use the column join, and I've also showed you how to use the shared primary key, where they actually have the same ID. That's how you know that they actually stick together in a one-to-one relation. This is the cleanest way, because in this way to join two tables, you are not modifying any of the tables themselves. You are actually creating a new table where you would have where you have the ID from one of your columns or one of your entities like this. So that means you would have a table with at least two columns. You would actually have three columns. It would have an ID itself, and then you would have the ID from one of the tables you need to join, and then you would have the other ID from the other table that you want to join. I have a captain and I have a spaceship right here, and I have made my join description on the captain side. This is quite important, and I've actually created an error on purpose that we will actually fix together as soon as I've gone through the whole setup right here and the syntax. But yeah, but we have a spaceship. We have a captain right here who has an ID. He has a name. She has a name, and then there's also a biography of who is this person right here. And then we have the spaceship that this captain is a captain for right now, and this is a one-to-one mapping. The captain can only be a captain of one spaceship in this scenario right here. And here we have determined that we want to use the JoinTable by using the add JoinTable annotation right here. And as you can see right here, it comes from the persistence package. So it's part of the JPA. All of the JPA stuff is in JavaX persistence. So then we have to give this table a name, and I've just named this because I'm using H2, so I know that it uses underscores instead of camel case. So it means that I've named this captain underscore space underscore ship, and that would be if you converted that into something in Java, then it would be captain and then capital S in space, and then capital S again in the ship. But we are using a snake case when we're dealing with H2, and actually all of your names will automatically be converted into snake case. So let us say that you have had a full name, and then with capital N in name, then you would actually have a column named full underscore name when you look into the database itself. That is a detail. That is exactly why we need JPA and Hibernate. That is what they do for us. They actually do all of that weird stuff. So when we come to a new database, then JPA and Hibernate knows how to actually act on this new database. And again, I'm using H2. This means that as soon as I start up my application, a new H2 database will also be started. Then we have this is inside the annotation right here. So now we have named the table. This would be your table name. Then we have join columns right here, and here we need to use the join column annotation, and we need to do that twice. One for the join columns, and then we would need to do another one for the inverse join columns. It is actually plural. This means that you could actually have multiple join columns that would end up with multiple inverse join columns. So sometimes you actually have a key containing multiple IDs on multiple pieces of information on a column, on a table. I will not show you any examples of this with this because it's quite rare, and you should actually try to avoid it if you can. But I might make another video about the joint, the composite IDs. Actually, that's actually what it is. When you have an ID that consists of multiple columns. Okay, so here now we have the join column. This means that this is the name of this will be the column name inside this table, the captain space ship table. Then we would have a column named captain space captain ID, and that would actually refer to the ID of this entity that we have right here, of the captain entity right here. Then on the other side, inside the spaceship, on the other side we would actually have a spaceship ID column, and again it is still in this table right here. So in this table named captain spaceship, we will have a new column named space underscore ship underscore ID, and this again will refer to the ID of this join spaceship right here. And as you can see, I've actually named all of my entities. I've prefixed those with join. You don't have to do that. It's just because I have 3 examples. And I've already created 2 other videos where you actually could see how to create a shared primary key join, and also how you could make a standard join, how it's usually done with a one-to-one mapping. I would say this join table here is definitely the cleanest one, because if you suddenly decide that you don't want to have a one-to-one join, maybe a captain can actually be captain on multiple ships at the same time. He could have a fleet maybe. Then you can easily change the join with the join table approach, because it is possible then just to put multiple rows inside that join table, and you will not have to change how your main tables they actually look. You don't have to change the spaceship or table or the captain table in order to change the relation from one-to-one to one-to-many, for instance. So it's quite flexible with this is a clean solution actually. If I look at the spaceship, my joint spaceship right here, then it has an ID. It has an automatically auto-generated value right here. What this will do, it will actually take the value from a sequence that is automatically created when my H2 database is started. Then JPA is actually so nice that it will actually see okay, we need to be able to generate values, and then there's a sequence named, I think it's named something with hibernate sequence or something like that, inside the H2 database, and then that sequence will then be used, and the default for that sequence is actually to add 1 per usage. So this means that if I create one spaceship, then that will take number 1. If I create a captain afterwards, then that will take the number 2, etc. But all of that, of course, I don't have to think about that, because that is what we get from JPA for free. So thank you very much for that. And then we have the fields from the spaceship. Those are description of the spaceship. What kind of description is it? Or what kind of spaceship is it? How much fuel do we have left? It's an integer, so that means that a whole number between 0 and 100. Fuel percentage. And then we have the max speed right here. This is a double. And of course, yes, the types could have been a lot of other things, but now I just chose this for this demonstration. I'm trying to demonstrate I am demonstrating the relations, not the types of the columns versus the types of the properties in Java. Then we have something else we need to add right here. We need to have the mapping, a one-to-one. As soon as you have something that is not one of the primitive types or one of the wrap primitive types, then you always, you have to add, you have to write the relation between this and the other, and whatever you're pointing to right here. This is a one-to-one mapping, so I'll just write one-to-one. And then the next information I give is, I'm actually saying that this is already mapped on the ship side. On the captain side. Whenever I use this map by, this means that then I'm telling JPA that this is mapped on the other side. That means in this case on the captain side, and it's mapped by the property named ship. By the property named ship. So this means you don't need to you don't have to map all the relations twice. Actually, you should not do that. You should not map them twice. Only map them once, and then tell JPA that this is mapped on the other side. This means that actually the captain would be seen upon as the master right here, or not master, the parent, and then the ship would actually be the spaceship would actually be the child. This means that when we have to save our entities, then we have to do it. When we want to link the captain with the spaceship, we have to do it on the captain side. I'll show you that. That's exactly what the error I put in on purpose will actually show us in just a minute. Then you have cascade right here and cascade all. This I'll make a separate video for the cascade types. This means that for instance, if you are deleting an object that actually points to other objects, then you can actually delete all of those objects by deleting the parent object. So this means that if I delete the captain, then I will also automatically have the spaceship deleted. This is wrong. This is something I forgot to delete. This is because I copy-pasted it from the primary key example. I'm sorry about that. And I also don't think we need the cascade, because we're doing all the interesting stuff on the other side. It's actually being mapped on the other side. So, yeah. So that is our spaceship. Let us just go back to our captain just to see how it looks. Here we have the cascade. Here it means something because this is where the relation and this is where we will link them together. We will link them together on the captain side. Now let us create some objects on startup, and the way that I have done that is I've done it 2 different ways, just to show that it's a small teaser actually for another video I made where you can actually see how to create data on whenever your application starts up. Spoiler alert: Liquid-based is the right solution, but this is the fast solution right here. We can use add post construct. This is not the Spring way, but it works. This means that after this component right here has been created, then this code right here will be run. And more Spring way is actually to use the event listener, or more Spring way. I actually don't know if it's a more Spring way, but I would say this is a nicer way actually. If you go to the event listener and then you listen for the application event started, and then you call your code. I would say this is the clean way. Post construct is a bit it works. Let us stop with that. In the post construct in this method right here, I've actually created the example that actually works. This means I'm creating a pyramid first. So I create a nice pyramid spaceship, and then I save my spaceship. Then I create a nice captain right here, named Brian, and then I save that. Captain right there, and I should actually then I save that captain right there. Let me just introduce this one right here, and this is the saved captain. And then I need to say, then I take the saved captain and then I set the pyramid. I could actually set the pyramid already up here. That would also have been okay because this is the captain that it's on the captain side that we actually link them together. So that means that here I have my captain, and then I set the ship, and then I save my captain again, and then I'm done with this example right here. In the other situation right here, then I do it all the way around, and it would not work. Let me just spoil that much. But here we have the pyramid. Oh, that's actually a box. Let me just rename that. Shift F6. Yeah, box. Thank you very much, IntelliJ. Then we save the box spaceship right there, and then we create a captain right here, and we save the captain. And now this time we try to set the captain on the spaceship. That means the other way around, and then we save it right here. And spoiler alert, this will not work. We will actually get them. We will not get them linked together because we need to set it on the captain side, because it is on the captain side that we have all of this. That we have mapped those. Where we have named the mapping and all. So this is the parent object, if you will. But let us start the application and actually see what happens, because we have a view directly into the database, because I have enabled the H2 console. As you can see right here, I've enabled the H2 console. I've set a very difficult to guess username and password. And I have, this is my database name, space right there, and application started up, and we can also see there's some output right here. App started events, and let us see, wasn't that what I printed out right here? I think it was. Yes, it was. So we already know that that the event listener way also worked. Let us go to the console right here, and as you can see, I've already it was actually already open, and then let me just log in again, because now it is actually a new instance of the database, because I just started our server. So here we have here you can see we have the captain spaceship. This is the join table. I'll not spoil it yet. Let us just go to the captain first, and let us look into the captain. Here we have the Brian, smart guy, and then we have Paul, the eager and happy one, and then we have, let me just go back to the spaceships and look at that. Then we have one pyramid, and the number ID with 6, that is the box that we have right there. Yes, so that's quite cool. So, but now let us look at the relation. Let us look at the relation table that we have right here. Spaceship ID, captain ID. So this means that it was only the first example that actually got mapped together. And this means when we have a relation table like this means that we can actually select something from the join underscore captain captain and join underscore space underscore ship. As you can see right here, camel case has been converted into snake case. So we have this is a relation. I'll just name this R for relation. This is C for captain and S for ship. So those are the aliases. Then I can create my where clauses down here, where R dot space underscore ship underscore ID. The relation table, it actually does not have its own ID column. I would say sometimes it's nice that it actually has its own ID column. If you want to go delete exactly one relation, of course you can still point them out with the other two columns, but it's just, I would say that it would be nicer with an ID column right there. I have to examine if that is possible in an easy way to actually get that. So we have the spaceship ID right there equal to s.id, and then we have r.captain ID equal to c.id like this. So it means now we have actually joined all of the two tables, the captain and the spaceship, through the join table, which is named so captain underscore space underscore ship. Let's press play, and here we can see we only get one row, one line right here. That's because the other. We created the pole captain and the box spaceship are not joined correctly. We can just fix that, of course. So let us just do that. So we will say we know it should be done on the captain side, so we can actually just say ship like this, and then we can name the box ship right here, and then we don't need to do anything else actually. So let us restart the server and actually see what we get. And we should actually copy this part right here. So we will just say copy. And we have to refresh the page. Yes. Refresh the page. Run. Go to why. We should get the login. Okay, I made an error, that's why. What happened now? Detached entity to persist. Because this has not been attached yet. So here we have the spaceship. And yeah, okay, that's because we actually need to save the captain first. Because or else the relation table, it needs the ID. The ID has not been generated yet, so we can actually not do that. So first we have to save the spaceship and the captain, one at a time. Then both of those gets an ID, and then we can then attach the ship to the captain like this. Box, and then we save this again. So it says captain repository.save like this, and then we save the save captain. This should work. Let us try that instead. You always need to understand how the database actually works a bit with the not a bit, but you have to understand what's actually happening under the hood. And that is sometimes a difficult part with JPA, and that's why some people sometimes then it totally gives up and say, "Oh, then I could just write all of the SQL myself." But I would say that is definitely not true. You will get a more consistent database if you use JPA, and your Java code will be much easier maintainable along with the database if you use JPA and Hibernate like we just do right now. Some people that likes Hibernate, they sometimes come with the argument that okay, what happens if you want to change the database, then you need to use JPA and Hibernate, right? But that situation, you can try to ask them how many times they have tried that in their career, and I would guess that the answer is probably 0, just like in mine. You do not just change the database for fun. So that's a bad reason. But the good reason is that, and the right reason is that you have Java code. You have your Java code, and you have your then you have your database that just sticks together. that you have a coherence right here, and as when you're a bit trained in JPA, you will find this very natural, and you will say that these annotations are it makes sense. Of course, when you have when you mention another entity, of course you need to tell JPA how should it be mapped, right? That's one thing. And then if you're using the join table, of course you need to give at least 2 join columns here. I would actually can we add an ID right here? I'd like to have an ID that had actually its own ID right here. That's actually the only thing I miss with this solution right here. But I have to look that up. That's actually what I want to show. As usual, my code is on GitHub. Feel free to fork it. And thank you very much for all the nice comments that you come with. They mean a lot. And hope to see you again soon. Bye bye.